So this topic is related to modes, and we have already discussed the topic modes, the percentage yield, empirical and molecular formulas, and how we can prepare the soluble and insoluble salt. Then calculating the apparatus error. So how we can calculate the error in our value due to the apparatus. So each type of apparatus has its sensitivity, and the term sensitivity refers to the smallest value which the instrument can record. That is referred to sensitivity of the apparatus. And if anything is related or any error is related to sensitivity, we call that as sensitivity error. So when we are using a balance, it is accurate to 0.001 gram. So this is the smallest value which a normally balance can measure. So that is also we also say the sensitivity of the balance is 0.001. Volumetric flask, it is 0.1 cm cube. To 25 cm cube pipette, it is 0.1 cm cube. And a burette start and end reading or endpoints, the certain uncertainty or sensitivity is 0.15 cm cube. How we can calculate the percentage error, the formula to calculate the percentage error. So the percentage error for each apparatus can be calculated. The sensitivity error, like the smallest value which the apparatus can record, divided by value which we recorded by using that apparatus multiplied by 100. So example, the next slide. If you want to calculate the error, if I say we are using a balance and measuring a mass, the mass of the object, the mass, it come out to be say 2.978 gram. This is the mass of the object, and we want to find the percentage error in this reading. So how we can calculate the percentage error? The percentage error is the sensitivity error or the least count. So the sensitivity error for a balance, because mass is measured by a balance, that is 0.001. So 0.001 divided by the value the value which we record by using the balance, that is 2.978. So this will be 2.978 and multiplied by 100. So it will be 0.001 multiplied by 100, and that is divided by 2.978. It come out to be 0.03%. But for example, when we are sometime when we are measuring a mass, we may use the balance twice. Like example, first we measured the mass of empty crucible or container. Say it was coming out as 1.076, and then we measured the mass of filled container, and that come out to be 1.476, and we want to calculate the percentage error in the measurement of the mass or the value of the mass. So how we can calculate the percentage error? And the mass of the substance will be the mass of a substance which is inside the container. So empty container is 1.076 and the filled container is 1.476. So when we take a difference of the two, when we subtract the two numbers, so it will come out as 0.400 grams. So that is the mass of the substance. And if there was a question, calculate the percentage error in the mass of the substance. So the least count of the balance is 0.001 divided by value which we calculated for the object, that is 0.4 into 100. But because the balance is used twice, we first measure the mass of empty container and then we measure the mass of filled container. So when a value is calculated, when the apparatus is used twice, it means the uncertainty or sensitivity error will be multiplied by 2. Is it clear? The concept that sensitivity error can be calculated or percentage error can be calculated. The sensitivity error or uncertainty divided by value recorded into 100. If the apparatus is used twice, if we use the apparatus twice, then we should multiply that by 2. So normally burettes and pipettes are used, and not pipette, most of burettes are used twice, like we read the initial volume, then we read the final volume. So uncertainty of the burette or sensitivity error in case of burette should be multiplied by 2. In case always with a burette it is always multiplied by 2, but for a balance it depends on how we carry out the calculation. So if we want to reduce this percentage error, like if we want to reduce the percentage error, we should use more sensitive apparatus or apparatus which is having a less sensitivity error. We should use that, or we should measure the larger volume or larger measurements, because if I increase the measurement size, that will reduce the percentage error. So to decrease the percentage error, you can either decrease the sensitivity error. And how you can decrease the sensitivity error? You can use apparatus with greater resolution or finer scale, or can measure more volume, more markings are there, so it can easily recognize and read. Or you can increase the size of the measurement. Is it clear, the concept of the percentage error in the apparatus? So it depends what kind of apparatus we are using. If we are using it twice, then it should be multiplied by 2. If it is only once, then it should not be multiplied by 2. Then reducing error in measurement of the mass. How we can reduce the error in the measurement of the mass? As we know, the percentage error is equals to uncertainty. It is having different name. You can say uncertainty, you can say sensitivity error, you can say least count, divided by the value recorded multiplied by 100. So reducing error in the measurement of the mass, how it can be reduced? By using more accurate balance, because if you use more accurate balance, it will have smaller uncertainty. If it is having smaller uncertainty, the percentage error will be reduced. Or by measuring a larger mass, because if you are measuring a larger mass, the denominator value recorded will be higher, so the percentage error will be reduced. And weighing the sample before and after addition, then calculate the difference to ensure more accurate measurement for a mass added. And example, calculating the percentage difference between the actual value and the calculated value. Example, if we calculated the relative molecular mass and it come out to be 203, but the real value, the actual value is 214. So how we can calculate the percentage difference? So the formula to calculate the percentage difference, if we know the standard value, so it will be maximum value minus minimum value divided by standard value into 100. If we don't know the standard, then it should be divided by mean. But in this case, we know the real value, so the standard value or real value is there. So when we are calculating a percentage difference, so for this example, it will be 214 minus 203 divided by the real value is 214 and then into 100. So it will come out as 5.41%. Then how we know that whether our experiment is accurate? So we'll compare two things. What we will compare? We will compare the percentage error with the percentage difference. Like using the apparatus will have percentage error. So if the percentage error due to the apparatus is less than the percentage difference between the actual value and calculated, so it means that the difference in the result is due to other errors. It's not due to the apparatus. Like our apparatus is accurate and still we are getting a difference. The percentage difference is there. So example, if you are getting a percentage error of the apparatus and that percentage error is coming out 2%. And when you calculate a percentage difference is coming out 5. So what it shows that your apparatus is accurate. There might be some other errors, maybe random errors are there due to sudden change in the condition, atmospheric change in condition, or atmospheric condition changes during the experiment that may leads to, or might be error due to the person, like maybe you did not record the value correctly. So if the percentage error due to the apparatus is less than the percentage difference, we conclude that the error is due to the other reasons but not due to apparatus. But what happens if the percentage difference is greater? The percentage difference due to the apparatus is greater than the percentage error is greater than the percentage difference. Then what we can conclude? We can say that the error is actually in the apparatus, the equipment. So we should use more sensitive or more accurate equipment. So sometime they ask you to calculate the percentage error as well as the percentage difference, and they ask compare whether the result or the difference in your value and the standard value is due to the apparatus. So how you can identify if the percentage error is less than the percentage difference? You will say that the apparatus is accurate and the errors are due to other reasons. But if your percentage error in the apparatus is higher than the percentage difference, it means the error are due to the apparatus which you are using. Is it clear? Any doubt in this part? Then hydrated salt. Hydrated salt means the salts which have water of the crystallization. Basically, we know salts are solid at room temperature. But what happens? Some of the salts have a tendency to trap the water molecule in the lattice. So as they trap the water molecules in the, it's not like it's a dissolved salt. It will be solid, but it actually trap the water molecules inside, and we call that type of salt as hydrated salt. And when we supply the heat energy, this will not melt instantly, but instead of melting, what will happen? It will lose its water of crystallization and it will become anhydrous salt. So a salt can be hydrated or it can be anhydrous. So how we can work out the water of crystallization in the salt or number of the water molecules present? So hydrated salt contain water of crystallization like copper 2 nitrate. It's written that it contains 6 water molecules, where anhydrous copper nitrate. So basically this is copper nitrate hydrated like CuNO3 in a bracket 2.6H2O. So this is hydrated, but when you supply heat energy, it becomes anhydrous copper 2 nitrate. So how we can work out the water of crystallization? Practically how it can be done? So for this purpose, we will use a crucible. So the water of crystallization in calcium sulfate can be removed as a water vapor by heating. So first what we do, we'll measure the mass of empty crucible with the lid. So empty crucible with a lid on it, we measure the mass. That is M1. Then we will place the sample like hydrated copper to sulfate, copper to nitrate. We place in the crucible, and we will measure the mass again. And the difference in the mass, like M1 and M2 are there. So the difference in the mass M2 minus M1 is actually giving the mass of the hydrated salt. So we'll get the mass of hydrated salt. Then what we'll do, we'll supply the heat energy. So when we supply the heat energy, this water will start to lose its water of this salt start to lose its water of crystallization. How we can make sure that all of the water of crystallization is being lost? So we have to cool down and then reweight again and heat to constant mass. What's the meaning of heat to constant mass? It means that we allow it until the mass does not change. Once the mass is constant, we are sure that all of the water is being lost. So example, what we did here, we weigh the empty crucible with a lid. That's the first point. Then example, we add 2 grams of hydrated calcium sulfate and reweigh again. Then heat strongly with a Bunsen burner for a couple of minutes. Then allow it to cool down and then weight the crucible again. And then heat the crucible again and reweight until it reaches a constant mass to ensure that the reaction is complete or all of the copper nitrate, hydrated copper nitrate loses its water of crystallization. Then how we can work out the mass of the water present in this hydrated. So if we know that, because when we subtract M2 minus M1, that gives us the mass of hydrated. What about the mass of anhydrous salt? Once it lost its water of crystallization and we supplied heat energy, that mass is M3. So when we do M3 minus M1, we'll get the mass of anhydrous. How to know the mass of the water? So hydrated salt minus anhydrous salt, what we'll get the mass of the water which is lost from it. And from mass of the water we can work out the moles and we can use the mole ratio to know how many water molecules are there. So example, sodium sulfate Na2SO4.XH2 has a molar mass of 322. Calculate the value of X. So we need the value of X. The total mass of sodium sulfate is 322.1. So if we subtract the mass of anhydrous, what will be the mass of anhydrous? So if we remove this water, so sodium are 2 multiplied by 23, sulfur is 32, and oxygen is 16 multiplied by 4. So this is the mass of anhydrous, this is the mass of hydrated. When we subtract, we'll get the moles of the water, and moles equal, this will get the mass of the water, and mass of water we can get the moles divided by molar mass, which is 18. So 180 divided by 18 will get 10 moles of water. So actually this value of X is equals to 10. Is it clear, this example, how we work out the water of crystallization? So basically the hydrated salt minus the anhydrous salt will give us the water of crystallization. So example, we have 3.51 grams of hydrated zinc sulfate. So it means that is the zinc sulfate with water. 1.97 grams of anhydrous zinc sulfate is obtained. So how we can use the data to calculate the value of X? So first we'll calculate the mass of water. How to calculate the mass of water? Hydrated salt minus anhydrous. So this is the mass of the water. Then because we have to take the mole ratio. So what is the mass of zinc sulfate? This is the mass of zinc sulfate, ZnSO4. and this is a mass of hydrated zinc sulfate ZnSO4 dot XH2O. So we have the mass that is 1.97, and this the hydrated was 3.51. When we subtract, we got the mass of the water. Then we'll find the moles. First for zinc sulfate, mass in gram divided by molar mass, so 0.0122. And then we'll find the moles of water, 1.54 divided by 18, we'll get 0.085. Then we'll take a simplest ratio. How to take a simplest ratio? We'll divide by the smallest value, so 0.0112, 0.0122 will divide. So this will come out as 1 and this one is 7. So basically it is ZnSO4 is 1 and XH2O is 7. So this is actually the value of X. So X is equals to 7. Is it clear, this example? How we work out the moles of water present in the hydrated zinc sulfate. So this was topic one. I will do some questions related to the topic. So topic one, I'm going through the objective, the syllabus objective. 1.1, you should know the term atom, element, ion, molecule, compound, empirical, and molecular formula that we did. Know that the mole, the definition of a mole, that its amount of substance or number of a particle 6.02 exponent 23. Then you should be able to write full and ionic equation, include the state symbol. That should be done. You should know. Then understand the term relative atomic mass, the definition, relative molecular mass. Molar mass means mass of 1 mole, and parts per million the concentration. Calculate the concentration in mole per dm cube and gram per dm cube. Able to use experimental data to calculate empirical and molecular formula, that's done. Able to use chemical equation to calculate the reaction masses, that is related to moles by using a moles, the ratio from the equation. By using the equation, you can use the ratio to work out the moles or the mass. You should be able to use a chemical equation to calculate volume, the concept of amount of substance, moles, the molar volume, the mass occupied by 1 mole of a gas, and you should be able to use this expression PV is equals to nRT for gases and volatile liquid which can easily be vaporized. Be able to calculate the atom economy that we discussed yesterday and determine a formula and confirm equation by experimental, including evaluation of the data. So using a ratio, basically this is also related to mole ratio. We should be able to work out this. Then measuring the molar volume of a gas, we can measure the volume of a gas by a gas rate that we discussed yesterday. Then able to relate ionic and full equation, displacement reaction, when one element displaces the other, displacement reaction, typical reaction of acid and precipitation reaction. So this is all about topic 1. These are further suggested practicals, like you can work on this, but it's not like it's the same practical will come in exam. Only the core practicals are important, which we have to learn the procedure as well. Now we'll do questions related to topic 1, which is about formula, equation, and amount of substance. So this is the assignment related to moles and acids. In question 1, how many protons, neutrons, and electrons are there in chloride? So we have chlorine, which is 17 and 37 with the charge 1 minus. So here A is equals to 37, Z is equals to 17. To find the number of proton, that is given by Z equal to 17 neutron, that is A minus Z, so 37 minus 17 equal to 20. And to get the electron, that is Z minus the charge, so Z is 17 minus and the charge is minus 1, so it is 18. And it is obvious because it's a negative charge, so it means it should have more electrons than proton, or one extra electron than proton. So the number of the neutrons that are 20, number of electrons 17, so number of protons 17 and number of electrons 18. So 17, 20 and 18. So C will be the right answer. In question 2, what is the relative formula mass of hydrated barium hydroxide? So how we can work out for barium hydroxide? So barium is there, which is 137.3 plus oxygen 16 multiplied by 2 plus hydrogen 1 multiplied by 2 plus about the water it's 18 and then multiplied by 8. So it will come out as 315.3. So D will be the right answer. In question 3, 11 gram of anhydrous sodium sulfate is dissolved in deionized water to form 70 cm cube solution. What is the concentration? So in mole per dm cube. So to get the moles equal mass in gram divided by relative molar mass. So 11 divided by 142.1, that will give us the moles of sodium sulfate, which is 11 divided by 142.1, so 0.07. And to get the volume, divide by 1000, so 70 divided by 1000, 0.07. So to get the concentration, that is 0.077 divided by 0.07. So 0.077 divided by 0.07, that's equal to 1.1 moles per decimeter cube. So C will be the right answer. I'm solving these questions so as an example, and later I will share this whole assignment so you can also try. Barium chloride react with sodium sulfate. So there is a reaction between barium chloride. This is aqueous and a solid is formed. So this type of reactions are known as ionic precipitation. What would you see when this reaction is carried out? So when two solutions are mixed together and a solid is formed, so we'll see precipitate. And what is the color of the precipitate? Because group 1, 2, 3, their precipitates are white solid. So we will see white PPT. Then write ionic equation for this reaction. Those who want to participate, they can also state their answer in a chat. Write ionic equation. So how to write an ionic equation? First we cancel out the common ion in aqueous. So chloride ion is common, we cancel out chloride. Sodium is common, in aqueous we cancel out sodium. So what we are left with, that is ionic equation. So we are left with one barium ion with a charge +2 as it is a group 2, and sulfate ion with a charge 2 minus. As a result, it will form barium sulfate BSO4 in a solid state. So that will be the ionic equation. So barium, the charge should be +2 as it is group 2, and sulfate valency is -2. So +2 and -2, and result forming a solid. So C will be the right answer. Then what is the maximum mass of barium sulfate that could be produced from 0.5 gram of barium chloride? So we can take the mass ratio. We have barium chloride and we need barium sulfate. So if mass is there, we can take the mass ratio. For barium chloride, the mass is 208 and it is only 1 mole, so it will remain 200. For barium sulfate, the mass is 233.4. So the ratio of the mass for barium chloride to barium sulfate, that is 208.3 to 233.4. But in the question, how much mass they provide for barium chloride, they ask for 0.5 grams. So if we have 0.5 grams, so this will be x cross multiply. So x will be equal to 233.4 multiplied by 0.5 divided by 208.3. So 233.4 multiplied by 0.5 divided by 208.3. So that's equal to 0.56 gram will be there of barium sulfate. So when we check the options, it is C. Then what is the atom economy by mass for formation of a barium sulfate? So barium sulfate is a desired product. And what is the formula for to calculate the atom economy in percentage? That is mass of a desired product I'm writing in short. That is mass of a desired product divided by total mass of the reactant or product, and that is multiplied by 100. So this will give the percentage atom economy. So the mass of a desired product, because our desired product is barium sulfate, that is 233.4. If this was 2 was written, then this will be multiplied by 233.4. But because it is 1 mole, so that's 233. Total mass of the reactant or product. So what is the total mass of the reactant? Because barium chloride mass is 208.3 plus sodium sulfate mass is 142.1, and that whole is multiplied by 100. So what it will come out, the percentage atom economy for this question. So it will come out as C, or 66.6%. Is it clear, this question? Another question. This question is about ethene. The global production of ethene is about 150 million per ton per year. So 150 million per ton per year. Calculate the number of molecules in 150 million tons of ethene. And 1 ton is equals to 1000 gram. So first we'll get the moles of ethene. Moles equal mass in gram divided by molar mass, and ethene is C2H4, so molar mass will be 12 multiplied by 4 2 plus not 4 12 multiplied by 2 24, and this will be 1 multiplied by 4, so total will be 28. Then mass in gram, how to get the mass in gram? So it is 150 million. So 150 million means 150 to 9 power 6 tons, and 1 ton is 1000 kg. So when I convert the ton into kilogram, I'll multiply by 1000, means I multiply by 10 power 3. and then to convert the kilogram into gram, I have to multiply again by 1000 and divided by molar mass, which is 28. So it will be 150 into 10 to the power 12. So 150 into 10 to the power 12 divided by 28 will get the moles. That will come out as 5.37 into 10 to the power 12 moles. But we need the number of the molecules, so we have the formula moles equal number of the particle divided by Avogadro's number 6.02 into 10 to the power 23. So moles multiplied by number of the particle will get the total number of molecules. So the molecules will be moles, which is 5.37 into 10 to the power 12 multiplied by Avogadro's number 6.02 into 10 to the power 23. So we'll get the total number of molecules of this ethene, which will come out as 3.2 into 10 to the power 36. Then the next part, ethene is commercially used in ripening bananas. Ethene level 100 parts per million in a room. So how we can work out this? So first we'll use the formula PV is equals to nRT to get the number of the particle, and by using the number of the particle we can work out the total number in the room. So I will write the formula here. So first what we use, we'll use PV is equals to nRT. So the pressure is given, we have the pressure, we have the volume, it's already there, temperature in degree centigrade, so we have to add 273. So 273 plus this, so it will be 294 Kelvin. R is there, the value of R is given, so we'll find the number of moles. After getting the number of the moles, we know, like in the room the ethene level is 100 parts per million. Like what does it mean? It means if you have ethene and the other gases in the room, so you will find 100 ethene in one molecule, or 1 million out of 1 million molecule, only 100 ethene will be there. So if you have this many molecules, because this n is giving the number of moles of the gas present in the room, so this value of n, so we can work out x here. Is it clear? This is the question we already discussed in the last session, so that's why I'm not calculating the value, I'm just explaining the idea again. Is it clear, this part? Any doubts? So we'll do next session, we will do more questions from this topic about moles and acids.